All right, this is going to be Algebra 2, Lesson 1-8. We are talking about linear systems word problems, and some teachers just like to say real world problems. So we are here. We are on our last lesson for the unit, and then we're going to do some test prep. So what are we doing here? Word problems. Let's do our word problem. And because I have technology, I apologize that you guys do not have technology in your notebooks.
Why can't we just write them on?
All right. So I'm going to simplify this as much as I can because Johnny has broken body parts. He can't write with his feet. Okay, so let's say I could write complete sentences, but I'm going to just say farm. We're on a farm.
Why?
We know a few things. There are 24 animals on the farm. Animals. We also know that there are 66 legs on the farm.
Dude, this is a tricky one.
We also know there are only pigs and chickens on the farm.
I want a pig.
All right, Johnny, I try to simplify as much as I can. Normally in a word problem, you'd have a giant paragraph and you'd have to dissect what's going on here. I've dissected it pretty well already, but we'll dissect it even more. We'll try to analyze the problem, get some information from it. So what's going on here? So we need to say solving word problems. Word problems. Here's the procedure. All right, so I'm waiting for pencils to stop so I don't go too fast here. Oh, do we want to give a shout out to Jack?
No. Sure.
Hi, Jack.
Hi, Jack. All right, so the first step here is to write what you know, what you are looking for. Or no, what you're looking for is step 2. What do we know? So step 1. Write what you know. All right, so we know 4 things essentially. We don't care that we're on a farm. I mean, that's great and all, but the math isn't going to change if we're on a farm versus, I don't know, a shed. So there are, what do we know about chickens? How many legs do chickens have?
4.
Wait.
I mean, 2.
So Sarah's growing up in the nuclear wasteland where they actually do have 4 legs. We also know pigs.
Can't laugh, stop.
So Sarah, on your nuclear wasteland, how many legs do pigs have? Is it like 15?
4.
No, it's 4. They're normal pigs.
They don't have 2 pigs. I mean, 2 legs.
God, sorry, what's going on with you?
So, what is the book that you read in high school where it talks about farmyard,
And 4-legged chickens?
where the pigs eventually walk upright, and it's a giant analogy for Stalin and all of that with Snowball the pig. God.
What the heck?
Oh, Animal Farm. Have you guys read Animal Farm yet?
There. Yes, I remember that.
You remember what? This is what this makes me think of. Pigs can have 2 legs.
Me either.
If they walk on 2 legs? I don't know. Okay, so we also know 2 other things. Total animals. Aminals. Let's spell animals right. How many total animals do we have?
See? Oh, wait. 24.
24. And what's the last piece of information we should write here?
60 legs. 66.
Yeah, that's the total legs. All right. So that was step 1. Hooray. Okay, so step 2. What do we want to know? What are we looking for?
How many chickens and pigs are on the farm?
I guess I didn't really specify in that question, so sorry.
Hi.
Don't add to it, please.
Send out.
I hate you.
Number of pigs. Now we know what we're looking for.
Don't make me laugh, it hurts.
So what are we looking for?
Number of pigs.
Number of pigs. Numero trace. Okay, then we have to get some variables because, again, we are in the unit. Take a look at our unit guide again. Our unit is linear systems, which means system. Definition of system again was what?
More than one.
More than. Oh,
Two.
I guess more than one is correct because it's two or more. So you're correct. Yeah, so it's having multiple equations, right? And then linear means we're all dealing with lines. So we need to get some variables here for our lines, for our system of linear equations. So let's go ahead and define our variables in step 3. So define variables. Usually, if I'm giving you some problem in this unit, I'm only going to be needing 2 variables. An x and a y, basically, or an a and a b, whatever letters you decide to use. What are our 2 things that we need to make into variables? Hint, it's listed in step 1. Yep. So what do we want to use for our variables for chickens and pigs?
Wait, what'd you say?
So we know chickens, chickens and pigs.
Look at all these.
These need to be variables. What variable should we use? What letter? Should we use star?
C.
You want to use
for
C?
P? Oh, for chickens?
I don't know, chickens. Chickens C? Pigs?
S.
S for pigs?
Why pig? Why S? Pigs. Oh, okay. I'm just kidding. P. Okay.
Because chickens is also plural? Okay.
I'm good, bro. I'm good, bro.
Alright, so far so good. Let's go to step 4.
Damn, son.
I'm making this very sequential.
What does that even mean?
Step by step.
Okay.
Follow these steps, you will get the answer.
Sequential.
Mm-hmm.
Sequential.
Step 4, this is probably the single hardest part of this. This is writing the equations.
Figuring out the problem. And Mr. Snell, you should not give me homework tonight because you want to be a nice person.
Sorry, Johnny. We'll work out the brain. I know you can't work out the muscles, but we can work out the brain.
No, but what is supposed to write?
Yeah, exactly. Write equations. What are we supposed to write for this?
Oh! Okay. We're supposed to write.
Write the equations. Okay, so how can we somehow combine the information we have from step 1 but turn it into variables and an equation? This is the hard part, so we'll make sure we think about this.
C plus B. Just kidding.
C plus B?
No, I'm just kidding, Sindo.
I don't know where B came from, but maybe C plus P.
I said P.
Okay, sorry. C plus P.
No, you did.
I said P.
No, you said B.
You said
I said P.
Yeah, you said B.
Oh shoot.
Okay, so chickens plus pigs, what should that equal?
66.
There are 66 chickens and pigs?
24 equals 24.
Are you sure? 24? Why 24?
Because there are 24 animals.
Oh, okay. That makes sense. If there are only chickens and pigs, they should add up to 24. I agree with you.
Yeah, boy.
So because it's a system problem, that means we have 2 or more equations. And I'll give you a hint here. I'm going to be easy. I'm never going to give you 3 equations. I'm going to be giving you 2.
Wait, so C is squared and then P is with the form of it because of legs, right?
You're onto something. Say that again.
So put C is squared.
C is squared.
So
Like
those
this?
are the legs because it has 2 legs, and then P is the fourth. Yeah.
The 4th power, like that?
Fourth part. Yeah.
Interesting. So you're counting the number of legs. So hold on. Let's create a new equation here because this was counting the number of animals. Let's do another equation to count legs. So you said C squared plus P to the 4th power
Equals 66.
equals 66 legs. So this was an equation to find animals, total number of animals. This was an equation to find total number of legs. So there's a problem with that second equation, and I'm going to let us think about it. It's really, really close though, John. You basically had it. But there's something that we need to fix about this. Technically 2 things, but it's the same thing twice. How can we fix that second equation and make it perfect? Because right now we're saying c squared. That means c times
What
c.
did we put in for, what did we add in the 24?
So the 24 is kind of dealt with. This equation, entire equation, was just animals. So we don't have to worry about the 24 anymore. We have the total number of animals, and this is counting the total number of legs. And Johnny was right in saying that chickens have 2 legs. But in order to... And he was right that c should be combined with the number 2. But it's not c squared.
C plus 2. No, times 2.
There it is, c times 2.
Legs.
So let's go back here. Let's erase this
What's wrong
2.
with you? You seriously thought chickens have 4 legs this whole time?
I did too.
Cyro, what?
I guess I should erase this plus sign so I have room for the coefficient.
Okay, Cyber.
So 2 legs per chicken and 4 will add 4 legs per pig. Now this makes sense because there are 2 chickens per leg, or 2 legs per chicken. I have 2 chickens attached to each of my legs, and I'm going to run around really fast and get all the feathers off. So this counts the number of legs. So if I say that if I plug in 1 for C, there's 1 chicken, then I count 1 times 2 is 2 legs. That makes sense. If I plugged in 3 chickens, that gives us 6 legs. That makes sense because if we plug in 3 for C before, we would somehow get 9 legs. 9 legs with 3 chickens, which doesn't quite make sense. Now this equation does make sense. Okay, so this is the hardest part, getting the equations, but from here, it's pure review. A system of linear equations. If I gave you these 2 equations, how do we solve them?
Well, I don't know how to solve it.
So technically, step 5 is just to solve.
But how do you remove the P?
Just remove the P.
But how?
So I'm going to rewrite this on my next slide. So it was C plus P. C plus P is equal to 24. And 2C plus 4P, is that 66?
Yeah.
Okay. How do I solve this? Remember, there are 3 things, 3 tools that we know how to use to solve a system of linear equations. Graphing was one of them. Graphing, something, and something. What 3 tools do we have in our toolbox to solve a system of linear equations? Graphing.
Okay, you guys.
Look up at the board, guys. I'm giving us a hint up here.
What?
1-1 through 1-3. Graphing was a tool.
It's graphing,
Okay, no, it's not right. You already said graphing.
substitution, and elimination.
There they are. Those are the other 2 tools. And that was from 1-3 to 1-2 to 1-1. All of these things, it's graphing, substitution, elimination. These are 3 tools to solve a system of linear equations. So, let's go ahead and solve. Which one do you think would be easier, substitution or elimination? I don't really like graphing. It's not as exact as I would like. Substitution or elimination? So, Sarah, you're our tiebreaker. Substitution or elimination?
Elimination.
Elimination.
Jerk.
Yeah, what's up?
Okay, so if I write them one above the other, let me rewrite this C plus P is equal to 24. All I did was I rewrote this equation underneath my second equation. So how can I multiply the top or bottom equation so that when I add them, I eliminate one of the variables?
Divide by 2?
Don't you subtract?
Oh, that's something new. We've never done that before, but we could do that.
What?
Divide by 2, the top equation, and you get really close.
Johnny's like, ask her really.
Chickens?
Instead of saying,
I think you just go straight down, Sindel, so it'd be like 2C plus 4P equals whatever that is, like you add those 3 things.
If you add them through, this is what's going to happen. So don't write this. I'm just going to show you why it doesn't work. If I add these through, 2C plus C is equal to, shout it out,
2C plus what?
2C plus C,
Oh, 3C.
4P plus P,
5C. 5P.
5P, and then this is going to be 90. Look, we haven't eliminated either of the variables.
I see.
we want to eliminate something. So let's go ahead and get rid of that. What can we multiply the top or bottom equation by in order to eliminate one of the variables? 2? Which?
Maybe? I don't know. You can like
Johnny, come on.
multiply everything by a negative.
Multiply which equation by a negative? You can only deal.
Bottom,
Okay, so you want to multiply all that by a negative?
right?
Okay, so if I multiply that by a negative 1 or negative something else?
-2.
-2?
Yes.
Say
Yeah.
negative 1. Or yeah, negative 2.
So if we multiply by -2, our new equation becomes what?
Wait, I don't know.
This new equation in red,
Negative 4c.
-2 times c is going to be
2c.
-2c.
Oh yeah.
-2 times p is going to be
-2p.
-2p. -2 times 24 is
26.
negative
What?
48.
-48.
Cyber 26.
I'm doing addition, sorry.
Am I right,
26.
Is-
I mean,
Yes.
if like for the 2c and negative 2c, wouldn't they just like cross?
They should get rid of each other. Yeah, they should
Yeah.
cancel out.
Check it
Hell
out.
yeah.
Do I really have 4?
So don't worry about that equation anymore. I'm going to cross it out with my highlighter so we can still see it.
No?
We do need to write this down. Yeah.
Wait, but not the second equation?
Well, I mean, we have to write the second equation, which was the first equation
No,
over
I
here.
mean like what you crossed out.
Please do copy that down. Yeah, copy it down and cross it out because we need to deal with this equation and this equation.
Okay.
All right, now 2c plus -2c. That's going to be what?
0.
That's going to be 0. 4p plus a -2p is going to be.
Hold on, you're going too fast.
Okay.
2p.
Slow down.
I'm going to slow down, but Daisy did get it. A 4p plus a -2p is a 2p. Is it a positive or a negative, Daisy?
Positive.
Yeah, so it's a positive 2p.
It's positive, Johnny.
Don't give me sex.
Shut up.
And then a 66
One half the person.
plus a -48.
Oh my good kid.
66 plus -48.
Negative. What?
Wait, hold on, let me solve it. Shh. Wait guys, wait.
Johnny, Daisy, are you trying this one?
Yes, I'm doing it.
I'm waiting for Cyber to answer in case she
Oh,
wants to.
It's
No,
18,
Johnny.
right?
It is 18.
Okay.
Okay. Now we have the equation 2p equals 18. Therefore, I need to do what to both
P
sides?
equals 9.
Wait, is it a positive 18?
Is it?
And then you plug
It's
in.
a negative.
Oh, is it a negative?
No, it's
Don't.
not. No, it's not. Mm-mm.
A 66
Why-
minus
oh, wait,
48?
never mind. 66 doesn't have a
Above,
negative.
dude.
Nah.
Oh, right.
It's good to think about, but yeah, you had it right.
Okay.
So 9.
So p equals 9. What does this mean, p equals 9, in the context of our problem?
Plug it into the first equation, the blue one,
Oh, plug it in? Okay.
right?
Yeah, we could do that.
So 2c plus 4 times 9 equals 66.
Maybe we should plug it into this one. Maybe it's a little bit easier.
Oh, fine.
You can do either one. You'll get the same answer.
Yeah,
So-
we should do that one because it doesn't have any. I don't even know what it is.
So c plus, my p is going to go right there, is equal to 24. Again, all I'm doing is I'm plugging this equation, I'm using this equation, I'm plugging in 9. So this 9 is going to be plugged in right here. C plus 9 equals 24. I'm going to subtract 9 from both sides,
15.
and c is equal to
15.
15. Okay, well now we have p equals 9 and c equals 15. Great! You have solved the problem except,
No, you gotta times 15 by 4, right? Or no, that's wrong.
well, what was the question asking for?
I mean, number of pigs, so no legsies.
So what is the number of pigs?
What? 15! No, 9.
9.
9 pigs.
So if the problem asked a question as a sentence, you answer as a sentence. You don't say
So
p
you
equals
were-
9. You
There
say
Number
are
of
9
pigs.
pigs in
Nine-
the farm.
9 pigs in the farm. Or maybe, yeah, even better yet, a complete sentence. That would be better.
And there are 15 chickens, right?
You can say 15 chickens, but you don't really need to because it's not asking for number of chickens. It only asks for number of pigs. There are 9.
We didn't even need to plug
Pigs.
it in, did we?
Yeah, we didn't need to plug in. So being smart about what the question is asking for is useful. But
Oh
I
my
think for
God,
most,
This is just one question, guys.
so I think for most of the homework assignments, I'm going to, or the homework problems, I'm going to ask for the number of pigs and chickens. I want you to find both.
Yay!
It's so much fun.
There are 9 pigs. That's the answer. Box it.
I don't know, Cider might get it wrong with their 4-legged chicken.
So all of this,
Not do animals.
Yeah.
all of this was step
Might
5.
say
Could we
there's
do a
8-legged
unicorn?
cow.
This was all step 5. Solve.
No, 4-legged cow.
I'm just kidding.
So you can use elimination, you can use substitution. If you're really exact, you can use a graph.
None.
Oh wow, I got it right.
All right. Are there questions? That's all we have for the notes.
So do we do our summaries?
Yep, summaries.
And for any like word problems, we could use elimination.
Elimination or substitution, whatever you want to use. All right, say bye to Jack.
Bye, Jack. Bye, Jack.
Bye, Jack.
Pikes.
I forgot he was.